Difficulty. So my name is Alex Jones. I'm the offering manager for Data Science Experience local product. So I'm looking forward to the opportunity to take a few minutes to talk to you guys about that today. I'm planning to just talk a little bit or show just a few slides in order to sort of situate Data Science Experience for each of you. And then I'm going to actually spend more time in terms of a demo just walking you through and showing you some of the functionality, some of the great areas of functionality that are inside the product. So first of all, so what is the IBM Data Science Experience? We call it a lot DSX. I'm probably going to use that term also quite a bit throughout the presentation. So DSX is a platform for developing and deploying analytical applications. It's for data science, as the data scientists, as the name implies. And it's really a platform which supports a data scientist throughout the life cycle of their analytical applications. So it supports them right from exploration and development of analytical models through the deployment of those models into production and the management of those models once it's in a productive environment. DSX is available in three different ways. It was initially developed as a cloud offering as part of the Watson data platform at IBM. It's been available since about June of 2016 as a cloud offering. A couple of months ago, about April, was our initial launch of Data Science Experience Local, which is what I'm going to be talking to you guys mostly about at the presentation here. That's essentially the same services that are available as part of the cloud, packaged up and available for installation and running on local hardware or on premises behind a customer's firewall. And thirdly, there's a desktop version of Data Science Experience, which is essentially a learning tool that can run on a laptop, but it's mostly designed for people to be able to learn about the technology, also a little bit of data science learning, and also potentially to deal with offline usage scenarios. So what are we solving with Data Science Experience? As we talk to data scientists that are in the market, we find that there's several different challenges or pain points that are coming up, which we want to address inside DSX. One of those is that data scientists tell us that they really don't like the fact that they are being required to have rigid tool sets. A lot of them are telling us that they are being essentially pressured either by especially in an enterprise environment where there's data science teams, to choose really just one a tool or one approach, one language, and that not to be able to, and they're not able to really deal with the breadth of tools and languages and capabilities that are out there. In the situations where they are able to have multiple tools, they find that it's hard to navigate between those separate ones and to connect to the data that they need in all the different environments, and to really get at all of the analytical capabilities that they require. They find that the environments that they're using are fragmented, and it's really time-consuming for them to move between them. They're having to ramp up with different communities and different ramp-up tools on each of the, or different ramp-up requirements for each of the tools that they use. And one of the things that's really important that they're telling us is that they find that as they move between different completely separate analytical environments, they lose track of the metadata and the data lineage, which is really required in order to prove out and test or demonstrate the validity of the results that they're coming up with, and to work again at that kind of production scale of analytics. And finally, they're telling us that they're in a very siloed, analytical silos. So they're finding that it's really hard for them to control the versions of the products. Also, they're finding that each individual data scientist tends to be responsible for actually controlling the entire analytical stack. And that means that they have to keep track of a whole bunch of different tools, a whole bunch of different libraries, all of which are delivering on their own schedule. And it's really, really hard for them to keep in sync. And what that does is that means that makes it very difficult for them to work together with other members of a data science team. When they share results, they find that the results are either difficult to reproduce, where different people are using different versions of their tools. Also, it makes it just really hard for them to share either results or to share an analysis where they take something to a certain point and then work with another member of a team who can then take it on from there. So those are really what we're looking to address with Data Science Experience. So I mentioned that we're talking about DSX Local here today. So DSX Local, as I mentioned, is the version that runs on a customer premises. So in this, it's a single installation. So that install includes everything that you need in order to build and deploy your analytical applications on your premises. But it's also extensible in that it works with the pieces of the environment or the analytical assets that are available inside your enterprise. So DSX Local includes a remote Spark, or it includes a Spark instance, but it can also be configured to work with a customer or your remote Spark version if you have an existing HDP cluster or any other Hadoop cluster. It can be configured to work with relational data sources as well as LDAP sources for authentication. And finally, it's extensible in that data science experience out of the box provides a certain set of libraries, but customers can add to those in order to get additional functionality beyond the curated set that they require for their analytics in their organization. Specifically, DSX includes things like in tools like Jupyter Notebooks and RStudio. Those are supported out of the box today. We also will be supporting Zeppelin Notebooks in a release that's coming out within just about a week, so in the very, very near term. There's a Spark instance that's included with DSX Local. As I mentioned, that can either be scaled out and used as your processing environment, or alternately, you can utilize an existing Spark HDP or other Hadoop Spark service. There's machine learning capabilities which IBM has developed in order to help create and manage and deploy machine learning models into production environments. That's all included with DSX, as well as a bunch of functionality that supports the collaboration amongst data scientists, as well as the community, which helps data scientists learn new techniques. And finally, Data Science Experience Local includes a tool which allows the administration of the hardware platform. So if you wanted to take a look just a second at the logical reference architecture, essentially what happens inside Data Science Experience, you start by defining connections to your data sources. So these can either be files that get uploaded to an embedded object storage, or alternately, IBM provides a set of connectors out of the box which you can use in order to define connections to your data sources. For the most common relational and Hadoop data sources. If you happen to have data that is in a format that we don't have an out-of-the-box support, an out-of-the-box connector, you can create those yourselves using basically the client that's provided by your data source provider. Once that data at runtime is used at runtime, it's loaded into Spark where the processing occurs. As I mentioned before, there's an embedded Spark instance within DSX, or you can use an existing Spark cluster of your own. Once the data, or using the Spark for processing and the data that's been ingested, you can then use a whole number of open source and IBM value-added tools for your data analytics. So as I mentioned, we support Jupyter and RStudio. In addition to that, there's areas that IBM's been doing some development and value add beyond open source in terms of easier or graphical tools for the creation of ML models, as well as a canvas, which is, for those of you who might be familiar with SPSS, an IBM analytic existing tool, that kind of a drag and drop sort of interface for model creation. Once the ML models have been created, then they can be deployed. Either Spark ML or scikit-learn models can be deployed into production in one of three different ways. They can either be deployed as online or real-time applications, where essentially we set up a REST endpoint and external applications can call that in order to get line-by-line scoring. There's a batch scoring interface which allows the processing of multiple records, as well as a streaming deployment which essentially allows the analytics to be built into streaming applications. So that's essentially what Data Science Experience at very high level is all about. I'm going to just go ahead now and leap into a demonstration. So the case that I'm going to be talking about is it's a scenario that's in the banking industry around credit card churn. I'm not actually going to be talking too much about the specifics of the credit card churn analytics, since it's a general audience here. But what I really want to do is I want to just sort of point out the most important and most interesting parts of data science experience and how it can be used to solve general analytic problems. All right. Okay, so when you go into data science experience, this is the initial screen that you see. You come in and you see it's a community tab. So the community tab really supports that ability of a data, or that helps a data scientist learn about data science techniques. So they see here a bunch of samples and example data sets and notebooks which support a combination of things. It supports to some extent helps them learn about general data science tools and techniques. It also some of the content that's here is very specific to data science experience. So, for example, some of the examples show things like how you actually deploy a particular model that you've created into production using the data science experience APIs. Inside this is showing data science experience local. It's a somewhat more limited community than you see inside data science experience in the public cloud, because a lot of our local customers really like to implement their environments in where they don't want their servers to have connectivity to the public internet. So these are all self-contained sources. And customers can also add their own individual best practices. So you can think of this as a sort of a combination of best techniques that IBM has curated and is providing to the community, as well as enterprise best practices. It may actually make a lot of sense for data scientists in the real world to also work with DSX in the public cloud, where they have access to a whole lot of additional community content, which is more dynamic and includes a lot more new learning data science techniques that connect and are available all around the public internet. So I'm going to go from here to projects. So I mentioned that one of the areas that is really important inside DSX is the ability to bring all of your tools, your data together, and work with other members of your colleagues and members of your data science team. So project is really the area where all of that's brought together inside data science experience. So this is where all of the analytical assets, the data, and the collaborators are brought together to work on one common set of tools that can be run by anyone within that environment. So what we're looking at here is all the assets that are available here. As I mentioned, the first step is to get data sources together. So if you see here, I have several data sets that I've already added that are to do with the credit card churn case. These are informations about customers, as well as summaries and churn rates for what have been experienced. In addition, so those were uploaded as files into DSX. Additionally, you can make, as I said, connections to your enterprise assets. This is an example of a DB data connection that I've created. So it's really easy to add those kind of connections in order to work with your own data. What I'm showing here is just the kind of connections that you'll need to make in order to work with a relational data source. You put things like all the sort of connection type information that you would expect in order to work with a particular table inside a relational data source. As I mentioned, we support a number of different we support a number of different industry-leading relational and Hadoop sources. Hadoop, Big Insights, Hortonworks is also supported as an out-of-the-box connector. If you're choosing Hadoop, or if you're choosing HDP rather, then you simply add this kind of information here. I also mentioned that if you do happen to be working with data sources that that aren't initially provided or aren't provided by IBM out of the box. You can add those by essentially referencing the JDBC connectors for that client, and in that case, once whatever source you've added will also appear in this list. So once you've got your data and are going back there, once you've got your data. One of the other things that's really important so that's grouping all of the data assets together that are applicable to a particular business problem. One of the things that you can also do inside projects, and one of the key things inside projects, is you can also add additional people, so colleagues inside your organization, so that they can really immediately and easily work with that data source, with those data sources and with those notebooks and things without in a shared environment. So if you take a look here, we see that I've created this particular project. I'm sharing it with a colleague. It's really easy for me to add a collaborator. So if I have someone else, a new member of the team, someone else that I want to work with, I can simply find them inside my organization. I can add them, and then I have the ability to choose what kind of level of access I want them to have. So if there's somebody that just needs to be able to see things like results, I can make them a viewer. If they're someone that I'm really collaborating with and expect to be working with together, then I can make them an editor or an administrator. An administrator just is essentially able to actually delete existing assets that are created by others. So by doing that, you can really expand out the number of people, the reach of the analytics, and you can make the analytics really available and very easily able to be run and expanded upon by other members of your team. So going back to that banking churn case, what I want to look at now. As I mentioned, so we've got the data, we've got the different people that can use it. I want to take a look a little bit at the actual analytical assets themselves. So as I mentioned, you have the ability to use RStudio for those people that really like working in our IDE. I'm going to show, in this case, more working with notebooks. What I'm looking at here, you can see inside this project, there's a combination of Python and Scala notebooks that have been used. Python, R, and Scala are all supported as languages. So what I'm going to do here is, for this churn example, or for this banking churn problem, what we've done is we've divided this up into essentially two parts. So the first part of this was an exploration workbook where the data scientists essentially are looking at the data that they have and are doing some basic analysis to try to figure out what the elements of the problem are that they need to be working with. So for those who aren't familiar with notebooks, we find that notebooks are a really fantastic tool for collaboration among data scientists, because by grouping together both text as well as and instructions, as well as code that can be executed and results all inside one environment, we really find that that's a fantastic tool for people to be able to share on those. So we find a lot of customers are doing things like having data preparation being done by data scientists, often a more junior or a beginning data scientist, and they can then hand that tool, that data source, or that notebook off to other members of the team who may be able to build upon it. Without having to go back and do a lot of rework. They can then build upon that, and they can actually do a lot more advanced techniques. So sharing within the notebooks themselves is something that we see a ton. So in this particular example, you're starting to see things like connections that get formed. Now, one of the areas that IBM's added things is we've made it really easy to add to start working with connections inside your environment. So I was showing a second ago where we were working with a data source. So you see here, if you want to add a data source, you see all of the ones which are available in your project. You can also see the connections to enterprise sources. So if I wanted to add and start to work with a data source that I've created and used, all I have to do is click a single button, and the data source is the code that allows a data frame to be created and worked with inside your environment gets added in one single click, and then you can immediately start to work with that. So if you see here that connection to the -db data source that I was using earlier, we've now got that in. It executes, and I can now immediately start to work with that inside my tool. So I'm just going to actually get rid of that one. But inside this notebook, what we're seeing, so once we've gotten into the data, we start to visualize that and work with that. So in this case, what we're using here is Brunel for visualization of data. So for those who might not be familiar with that library, that's a visualization library which was developed by IBM Research and has been contributed to open source. So data scientists can use whatever they like. In a lot of the IBM examples and things, we like to use Brunel because it provides a really quite nice, in a fairly simple to use interface, it provides a really nice view of data. So in the banking churn example, it's really easy here for the data scientists to see that they've been experiencing an increased level of churn over the years. In this in this particular credit card example, it's pretty typical in the industry to be seeing somewhere around a 20% churn in their credit card customers on a yearly basis. They started off within that range, but what you're seeing is that's increasing over time. So it's definitely something that's a concern to them and they may want to deal with. As they go through inside this notebook, they're able to start to make some particular. They can load their data in, they can massage it a little bit, and then they can start to visualize it in various different ways. Here they're seeing that the amount, the income for their customers varies across the various states. Obviously, they're going to be most interested in the people that have the highest income. And then they can start to look at the aspects of the actual churn that's occurring. So in this case, what they can see as they look at the distribution of the churning customers across various different characteristics, they see that they're churners here. And if you like, inside the Brunel, you can concentrate just on, for example, the churners. You can concentrate just on those who aren't churning. They can see that that the age profile for their non-churning customers is significantly older than the age for their churning customers. So they seem to have a problem with millennials. Also, they can see it doesn't seem like there's a big difference. This is looking at things based on other profiles. So for things like sex or other characteristics, excuse me. So things like sex don't make a particular difference. A little bit of a difference in terms of the education level. They're seeing that the more education level that people have, the less that they're churning. They are seeing, though, I'm sorry, excuse me, the levels above, that's actually showing the level of activity. So how much they're using the card. The less they use the card, the more likely they are to churn, which makes a lot of sense. So finally, what they can do is they can look at where their churning customers are located geographically. And in this case, they see that they have a particular problem on the West Coast, particularly somewhere like Oregon, where they're seeing actually nearly a 70% churn. So what this is an example of inside this, as I mentioned, I don't want to deal too much with the particular case, but with a number of fairly simple steps, they can analyze their problem. And in this case, they see that they've got a churning problem, and it's factors like the education level a little bit, how frequently a card is used, the geographical location of the customers are really important. So these are things that they'd want to use as a essentially as features in their ML development. So moving from that notebook, there's a couple of ways inside data science experience that once a customer, or once they've done a lot of, or once the data scientist has done analysis inside their environment, they can create, there's a couple of ways that they can actually, and satisfy themselves about the factors that are important. There's a couple of ways that they can create machine learning models and deploy those models into production. So one of those ways they can use notebooks. So there's a set of APIs that are available inside data science experience, which essentially allow the creation of SparkML or scikit-learn models, and they can create those. In this case, what we're seeing here is they're able to do things like they can divide their data set up into training, test, and validation sets. They can then, assemble a vector. They can essentially binarize their information. They can assemble a vector for creation of the model, and then they can actually run that model themselves. Once it's created, they can see they can basically evaluate its performance based on things like area under the ROC curve, and then they can deploy that model into here. This is saving it into the DSX repository, and they can create, as I mentioned, deployments of various different types. They can create like a,
Hey, Alex?
Yes?
Just doing a quick time check because we're running a little bit long into the other topic. So
Okay. I'm off. So essentially, this is I have one more step I wanted to take after this. So this is showing how you can create those ML models and then you can deploy them. There's also, as I mentioned, some interesting IBM value adds in terms of making that process easier. So we have a graphical approach for creating a SparkML model, which essentially follows the same steps as you were seeing above, but is doing it in a way that's much more automated and easier. So if I wanted to take a test creation, I have the opportunity to either create an automatic, I can do this automatically or manually. In this case, I just wanted to show what's available if you go through with a manual approach. You select what data you want to make available, and I'm not going to go into the last couple of steps, but essentially what you can do very graphically, you just essentially say, I want to create this, I want to use this target, and then the system goes in and it automatically does the steps that you were seeing in the previous notebook. So it basically automatically creates a vector that can be used for the training of the model, and then you can select which appropriate models you'd like to try as a starting point for your own evaluation, and those all get created, and the results, you can evaluate them, the evaluation results come back, and you can see those in your environment. So that shows essentially how you can, inside data science experience, how you can start off with an exploration and an evaluation. You can move from there into creating your ML models and deployments, either in programmatically with APIs, or you can do it graphically with tools like the model builder or graphical flow. And then finally, what you can do is, once you've deployed that, there's model management functionality, which allows you, or an administrator in the environment, to look at all of the models that have been deployed into production. So you can see across all of those which of them are performing well, which of them are following below certain thresholds and perhaps should be reevaluated or refreshed. And it lets you see things like which of them, and as well as information like which of those are the most invoked, which of them are performing the best in terms of their performance, as well as the characteristics of the users, who it is that's inside their environment that's actually using the service. So this is a good example of how DSX, or what this is really showing is how DSX really takes you right through that analytical journey from when the model is being, from exploration of a business problem, creation, usage of the data, right through the creation of models, and then the deployment and managing of those models in production. Thanks very much. This was just a bit of a whistle stop, but hopefully you can get a chance to go on and take a look at Data Science Experience yourself. There's either with the desktop version, which is free, or there's a free public cloud version that you can go in and check it out yourself and play around and hopefully find a lot of useful insights.